The next format we have here, guys, is going to be y equals x minus alpha squared times by x minus beta. And this is a situation where essentially we have a squared factor and a non-squared factor giving us our cubic. And well, in this case, switching over to Desmos, and in this case, what we have is we would have this sort of situation here. So in this one, I've gone ahead and graphed y equals x plus 1 times by x minus 1 squared. Now, just like in the other one, we can see that x minus 1 is what we're going to get when we solve x plus 1 equals 0. But the interesting thing is now that we have this squared here, our x minus 1 becomes a turning point intercept. So the graph comes all the way down, gives that x-axis a little smoochy there, just a little bit of a... And then it goes back up because it just touches it with a little turning point and then it comes back. So we can zoom all the way in here and it's always going to be just approaching that point of 1 there. And so that is the ins and outs of how we do a squared cubic graph, if that makes sense. So one of the factors is squared there. The final type of graph that we're going to get here, guys, is going to be a y equals x minus alpha or cubed graph. And that is just a point of inflection graph like we had before. So just to show you again, though, if we go over to Desmos here, you can see that we just get our point of inflection at the intercept like we would expect with a x minus any h value graph. So that's nothing special about that one. Anyway, now let's jump in and look at how we can sketch some of these questions.